Okay, so I'm going to go over quiz 2-4, and I'm going to do both versions in the same video. So make sure you're paying attention to what version you have. So this first one is version A. And it says the graph below shows the relationship between the number of gallons of fuel remaining in a truck and the number of hours the truck has been driven. So we're talking about putting gasoline in a truck and then it driving over a period of time, and when will it run out of gasoline. And so on version A, the first question asked about the x-intercept, which is right here. It is 20, 0. And so if I look at this graph, what's happening is the truck is running out of fuel after it's been driven for 20 hours. So this is hours, this is gallons. So the number of gallons of fuel in the truck before any driving occurred, the number of hours the truck can be driven before running out of fuel. So it can drive for 20 hours and then it will run out of fuel. If I'm looking at version B, okay, so version B, I will do in red. So anytime you see version B, you're going to see red pen. Okay, it was the same question, but it asked you about the y-intercept. What did the y-intercept represent? Which is up here at 0 to 100. And this would be 0 hours, 200 gallons. So the truck started with 200 gallons of fuel. And so the one that says that is A. Okay, so the number of gallons of fuel in the truck before any driving occurred. All right, now on both of them, both A and B, the part B, which actually was extra credit, it was the same thing, just finding that equation. What is the equation of this line? And so we did talk about this one in class already. You find your slope by picking 2 points. So I'm going to use my x and my y-intercept, and then my slope is the fall and the run. And so here I'm falling 200, so that's negative 200, and I'm running 20. So that equals negative 10. So my equation, which is part 1b, is y equals negative 10x plus 200, because that is your y-intercept. And I know you can't see what I wrote, but negative 10x plus 200, because that's where we started. Okay. Same thing for version A. It is the same exact equation. You found it the same way. You could have also taken those 2 points and plugged them into Liston's spreadsheet. Just so you know, another way to write it is y equals 200 minus 10x, because I start at 200 and I'm taking away. All right, let's go back to version A. Number 2, the water level of a river was measured each day during a 2-week period. The graph models the linear relationship between the water level of the river in feet and the number of days the water level was measured. So which statement best describes the y-intercept of the graph? And I actually think, yep, version B is exactly the same question. So it wanted to know, what is the y-intercept? Okay. And so if I'm looking at this, the y-intercept, we always call the y-intercept our starting point. And so I started at 0, 16, so 0 days, 16 feet. So the starting point, or sometimes you could see it as called the initial. So start is the same thing as initial. The initial water level was 16 feet. Okay. On version B is the same question, it's the same answer, it's just in a different spot. Initial water level was 16 feet. Okay. Number 3 on version A. Okay, we're on version A. It says a student graphed f of x equals x and g of x equals f of x plus 3, which means g of x equals x. I'm replacing x with the f of x plus 3. And if you graph both of these on the coordinate plane on your graph paper, right? And I say graph paper, I mean the graph page on your calculator, then you'll see that the whole thing moves up 3 units. Anything on the outside makes it move up or down. So on version B, we're changing this. So f of x equals x, and then g of x is f of x minus 3. So that new equation is x minus 3, and that means the whole thing shifts down. It only gets steeper or less steep if you change the number in front of x. All right, turn it over. And here's where I have two different things. So I'm going to look at version A first. And so this is version A. So if your graph doesn't look like this, you don't have that same problem. And it says it shows the relationship between the number of dollars a worker earns and the number of hours worked. What does the slope of the graph represent? Slope is always the change in y per change in x. Change in y is money, change in x is hours. So it's the amount of money earned per hour. Money per hour. And then part B said, what is that equation? And so you needed 2 points, so 0, 0, and 40, 320. And you could make a table. And if you had tried to count it, you can't just go up, you know, however many and over however many, because these boxes are not going by ones. So some of you tried to go 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you got 4/5, which does not work, okay? Because my slope is really up 300, my change in y, my change in x, or my rise. And then my run, my rise is 320, my run is 40, which equals 8. So now I know my equation is y equals 8x plus 0, because 0 is where we started, but we don't need to write plus 0. All right, version B. Joni has a parakeet, and she noticed that the parakeet chirped a lot. She decided to count the chirps, and she plotted them to give the graph below. What does the slope of the graph represent? So slope is change in y over change in x. Okay, this is version B. And so my change in y is the number of chirps, and my change in x is the seconds. So it's the chirps per second, the number of chirps per second, which is D. You could also go back and you could label things, right? So this is the number of seconds. That's x per y. And this is just the y value. And this is y per x, which is what we want. Okay. Same thing, your part B was also to write an equation, so you need 2 points. So here's a point and here's a point. And so you count up how many? We're going up 10. So my rise is 10. Over my run, which is 5, and I'm getting those numbers by looking at the graph. Up 10, right 5, which equals 2. So that means my slope is 2, and my equation is y equals 2x plus 0 because I start at 0. Okay, number 5. Let's see. Number 5 on this one up here is version B, and this one down here is version A, but they're the same question, just different numbers. Trina's paycheck earnings varies directly as the number of hours she works. Remember we talked about that. Varies directly means you can set up her proportion. If she works 19 hours, she earns $160.55. What could she earn if she worked 40 hours? So on top I put hours, on the bottom I put money. So over here I also have to put hours, in the bottom I put money. And then I cross multiply. So I do 160.55 times 40 and then I divide that by 19. And I don't actually remember the answer, so give me just a second. Okay, so I put it in the calculator, and 160.55 times 40 is 6422, and then you divide that by 19 and you get 338. On version A, it was the same thing. 19 hours goes to 187.15, which is your money. And what would 40 hours, how much money is that? So again, we cross multiply. So I have 187.15 times 40, and that gives me 74.86, and then I divide that by 19, and I get 394. Okay. All right, one more. Number 6. Let's see. Number 6 talks about the relationship between the number of cookies a presenter had at a convention and how many she had left to give away and the number of presentations she had made. And so on version B, it asked about the x-intercept. The x-intercept here is 6, 0. So 6 presentations, 0 cookies left. So the number of cookies the presenter had before making any presentations, the maximum number she gave away at every means your slope usually, so that's definitely not it. Per is also a thing for slope. So this is the maximum number of presentations the presenter made before running out of cookies. Remember, this is 6 presentations. So that's how many she had, and then she ran out of cookies. On version B, it was the same question stem, but we wanted to know what the y-intercept meant. So the y-intercept is up here. It's 0, 180. So 0 presentations, 180 cookies she had to give away. So it's the number of cookies the presenter had before making any presentations. And then part B was to write the equation. And so your y-intercept is 180, but your slope, you needed 2 points. And so I'm just going to use my x and y-intercept. And so my slope, I am falling, and then I'm running. You definitely want to be looking at that graph and saying, oh, it's going up or it's going down. And if I'm falling, I need a negative slope, which some of you had the right number, but the wrong sign. So I'm going to fall 180, and I'm going to run 6. If I simplify that, I get negative 30. So that means my equation is y equals 180 minus 30x, or y equals negative 30x plus 180. And it was the same exact thing on version B. Same slope, so y equals 180 minus 30x, or y equals negative 30x plus 180. Okay?